Aloha, my name is Zach Bramble and I'm a Marine Science Master's Candidate here at Hawaii Pacific University. I'm excited to share with you our research on the Great Pacific Garbage Patch Fish Assemblage, debris-associated community plastic ingestion in the Northeastern Pacific. Please allow me to introduce you to the community of fishes inhabiting and interacting with plastic marine debris where it is most concentrated in the North Pacific subtropical gyre, who among those fishes ingest plastic, and the types of plastic they ingest. We are motivated to understand the fates and impacts of plastic debris in the ocean where it is rapidly accumulating and we don't completely know where it all goes. It is difficult to fathom that so much plastic has accumulated in the ocean that it forms habitat for otherwise reef-associated and coastal species, that it is also transported to the deep ocean roughly halfway between Hawaii and the U.S. mainland. Our study of plastic ingestion by fishes further accounts for plastic marine debris towards a global budget and informs us which species may be more susceptible to harm. My goal today is to first introduce you to the debris-associated fish assemblage, specifically fishes from the Great Pacific Garbage Patch, such as the jawsome cookie cutter shark on the left, then report our current findings and promote our next steps. Our precious samples were opportunistically collected as incidental bycatch of the Ocean Cleanup System 2, also known as Jenny, which has been deploying to the Great Pacific Garbage Patch to remove plastic debris for several years. Samples are kept frozen and shipped on dry ice and arrive to our lab in Waimanalo once cleared by U.S. Customs and Fish and Wildlife Service. Once in the lab, I dissect individual fish samples, extracting their complete gastrointestinal tract, then sieve their gut contents to 1 millimeter. Contents greater than 1 millimeter are manually examined under microscope to extract suspected plastic particles, which are then positively identified with attenuated total reflectance, Fourier transform, infrared spectroscopy. Now, let's meet the fishes. The assemblage includes flying fishes, yellowtail amberjacks, blue sharks, pygmy sharks, and cookie cutter sharks, all expected in the deep ocean or pelagic zone. We also have sargassum fish, which are anglerfish adapted to live at the surface by clinging and camouflaging to floating sargassum mats, but are now similarly attaching to marine debris. Both fang blennies and sargents are reef-associated species now finding similar nooks within debris items. The debris has become their reef. Here's a look at the total lengths, or the length from tip to tip, nose to tail, of each species listed by common name. While tight groupings indicate adults, the wider spreads of flying fish and yellowtail amberjacks likely represent multiple species of flying fishes and multiple age classes of amberjacks. Through 135 dissections, we have observed no plastic ingestion by the reef-associated species, while all of the pelagic species had some level of plastic ingestion, ranging from a low of 10% in cookie cutter sharks to a high of 78% in blue sharks. In total, we recovered 118 ingested plastic items from 33 fishes, including 100 mesoplastics and 18 microplastics, mostly line, some fragments, a few sheets, and a foam. All plastic items were buoyant polymers to be expected in surface waters, including polyethylene and polyethylene polypropylene blends, several polypropylene lines and fragments, ethylene vinyl acetate fragments, and a polystyrene foam. Here we look at the longest length of each recovered plastic by polymer type and ID. Recovered fragments were usually about 1 centimeter, while lines were usually about 3 centimeters and range from 1 centimeter to over 8 centimeters. The mass of plastics ingested were typically less than 100 milligrams, and the mean mass of plastic ingested was 0 in all but blue sharks, who averaged over 200 milligrams of plastic ingested. Our finding of no plastic ingestion by otherwise reef-associated species suggests that diet and feeding strategy influences plastic ingestion. The small size of prey consumed by both blennies and sargents resulted in gut contents less than our threshold for recovering plastics. These species may ingest even smaller plastics, but may be unlikely to ingest plastics greater than 1 millimeter. Also, the selective feeding strategy of ambush predation by sargassum fish may limit their intake of plastic. While prior study has documented only a 3% frequency of plastic ingestion, our observation of 78% in blue sharks may be due to their juvenile behavior or may be an anomaly given our small sample size. Our observations of plastic ingestion by pygmy and cookie cutter sharks are the first known records of plastic ingestion by these species. Further study is definitely needed to assess the risks of plastic ingestion to these threatened and unassessed species. In perhaps our rarest observation, we documented secondary ingestion of plastic from myctophids to amberjacks, providing evidence of trophic transfer. Further study is needed to understand how much trophic transfer is occurring and the potential transport of buoyant polymers to depths by vertical migrators like myctophids and pygmy sharks. Our next steps include continued dissections focused on sharks and amberjacks, and comparing plastics ingested by garbage patch fishes to the garbage patch itself. Check out these great references to learn even more about plastic marine debris. I'm incredibly grateful to all my co-authors, advisors, and Center for Marine Debris Research colleagues. A special thanks to the Ocean Cleanup for their funding and precious fish samples. And thank you all for listening. Aloha.